In Holmes County, Ohio, a single 2 by 4 foot solar panel can keep an Amish family's safety lights burning for a year. And that tiny system is exactly why the electric bill never comes. If that number just stopped you, stay here. Subscribe to Tradition Done right now and turn on notifications. The algorithm will not bring this to you on its own. Hit like so someone else finds this today. I am standing at the edge of a working Amish farm where the power system is so small, so quiet, and so deliberately hidden in plain sight that most people drive right past it without ever understanding what they are looking at. What I found was not a futuristic energy experiment and not a rustic museum piece. It was a working solution, refined over generations, built to do one thing modern life keeps failing to do: provide enough power without handing control to the utility company. A few panels, a battery, a simple charge controller, a light where it is needed, a motor where it matters. Nothing more than that, and yet the whole thing changes the cost of living on the farm in ways that most people never stop to calculate. The first thing that hits you is the contrast. On one side, there is the modern household with monthly bills, rate hikes, hidden fees, peak pricing, grid dependence, and a constant low-level anxiety that never really leaves. On the other side, there is a farm in Lancaster County or Holmes County where the family chooses the load, chooses the timing, chooses the limit, and never has to wait for a utility company's permission to turn on a light. That difference is not just technical. It is philosophical. It is economic. It is power in the deepest sense of the word. And that is why this story matters. Because once you understand how Amish families have used standalone power for generations, you stop thinking about electricity as a service and start seeing it as a system of control. The system on the Amish farm is not built to impress anyone. It is built to stay alive in the real world. It works in the barn, in the shop, by the buggy, and in the daily rhythm of a family that has learned how to live with less dependence and more discipline. In Holmes County, the panels are often small enough to blend into the roofline. In Geauga County and Wayne County, the same logic appears in workshops, greenhouses, and outbuildings, where a battery bank quietly handles the work that used to require fuel lamps or dangerous open flame. In Indiana settlements, the pattern repeats with local variations, but the principle stays the same: keep the power local, keep it limited, and keep outside systems from taking over the life of the household. That is not a trend, that is a boundary, and the more I looked, the stranger it became. Because this was never presented to the public as a serious model for ordinary families. Instead, it was treated like a curiosity, a cultural oddity, something quaint and old-fashioned. But the numbers tell a different story. The Amish were not rejecting electricity because they were ignorant of it. They were selecting only the pieces that served the farm, the family, and the faith, while refusing the kind of full grid dependence that turns convenience into monthly obligation. You can see the logic in every part of the property. A light that only turns on when needed. A battery charged for safety, not luxury. A small motor used for a specific task. A system sized to the job instead of sized to the dream. That is what makes this so powerful. The method is not complicated. The discipline is. And once that discipline is in place, the cost structure changes completely. What I found was a practical energy system hiding inside a cultural tradition, and it raises a question that should make every viewer stop and think. If a family can keep the lights on, keep the tools running, and keep the bill at zero by designing the system around independence instead of consumption, then why have so many of us been taught to accept the opposite? Stay with me, because once you see how this works on an Amish farm, the next question becomes impossible to ignore. What else have they been doing this way for generations while the rest of the country paid for the privilege of depending on the grid? If you stand on a back road in Holmes County, Ohio, and look at the way an Amish farm actually works, the first thing you notice is not absence, but precision. You notice the barn light glows without a utility company. You notice the batteries are hidden, the panels are small, The wiring is simple, and the whole place feels built around one rule: use only what you can support yourself. In Lancaster County, Pennsylvania, that same logic has been refined across generations, with a huge settlement of about 40,025 people in 240 districts, while Holmes County has about 36,155 people in 292 districts. That scale matters because this is not a novelty or a fringe experiment. It is a living system spread across whole communities. In places like Geauga County and Wayne County in Ohio, and through Indiana settlements as well, the same pattern repeats: practical energy, limited dependence, and a deep suspicion of outside systems that demand obedience later. The Amish relationship to electricity is often misunderstood because outsiders look at the surface and assume there is only one rule: no electricity at all. That is too simple. The real rule is stronger and more interesting. They avoid dependence on the public grid because once a household is tied to the grid, it becomes tied to the habits, prices, maintenance, and authority of the grid itself. So the Amish have spent generations building around that problem instead of surrendering to it. In many communities, that has meant batteries, solar panels, propane, diesel engines, and small standalone systems that power only what the family and the church district consider acceptable. What you see in a barn or workshop is not random improvisation. It is the result of a community-wide discipline that has been tested in daily life for decades. In Lancaster County, the farms are dense, the roads are narrow, and the work is tightly organized around family labor. A morning begins early, often before sunrise, with chores that depend on controlled, limited energy rather than abundant convenience. If a family has electric lighting at all, it is usually battery-powered lighting rather than house wiring from the grid, and the power source is chosen to do one job well, instead of trying to imitate a modern suburban home. In Holmes County, where Amish solar adoption has been especially visible, one report from NPR described solar panels charging batteries that run buggy safety lights, replace dangerous gas lamps in barns, and sometimes power a small appliance or portable light. That detail tells you everything about the mindset. The system is not designed for excess. It is designed for usefulness, safety, and control. The same pattern appears in Wayne County and Geauga County, where local Amish life has adapted in quiet but very specific ways. A small solar array on a roof may charge a battery bank for a single purpose, like a water pump, a woodshop motor, or a light used where there used to be a fire hazard. The point is not to modernize everything. The point is to remove friction without surrendering the community's boundaries. That is why the panels are usually modest, often just one or two panels, not a huge roof covered in commercial hardware. The same restraint governs the use of diesel or gas generators in some groups. They are tolerated when they serve work, not lifestyle. In other words, the technology is always subordinated to the community, never the other way around. Indiana settlements follow the same principle, though local practice can vary from one church district to another. The important thing is that the Amish are not one monolithic block. Different communities draw the line in different places, but the underlying logic is the same: preserve the family, preserve the farm, preserve the faith, and keep outside systems from shaping the inside life of the home. That is why one settlement may accept solar for a shop, while another uses propane or a generator for specific work equipment. The settlement itself becomes the real energy policy. It is not written by a utility commission. It is enforced by custom, shared expectation, and generations of lived experience. When you look closely, daily life in these communities is built around energy that must be earned, stored, and rationed. That changes everything about the rhythm of the day. If lights are battery-powered, then the family uses them carefully. If a pump is run from a standalone system, it is used when needed and not left to idle. If a workshop has a small electric motor, it is connected to a specific task. rather than the whole building being quietly soaked in consumption. Even the choice to use solar panels at all came from the same practical instinct. A 2008 report on Amish solar adoption described simple standalone systems as a couple of panels and a battery used for specific jobs, not for plugging a home into a dependency loop. That small detail is one of the most revealing things about Amish life. They do not chase power for status. They only keep what still lets the family remain free. And that freedom has a cultural memory behind it. The Amish have preserved this way of thinking not because they are afraid of change, but because they are careful about what change does to a community over time. One generation learns from the next that convenience can become control, and control can become dependency. So a child grows up seeing why the barn light matters, why the batteries are maintained, why the panels are kept small, why a certain machine is allowed and another is refused. By the time that child becomes an adult, the system is no longer a set of rules. It is simply the way life is done. That is what makes the Amish context so important here. The visible object may be a solar panel, a battery box, a generator, or a small motor, but the real system is older than any one device. It is a culture of selective adoption, where the community keeps what serves the farm and rejects what changes the farm's direction. In Holmes County, Lancaster County, Geauga County, Wayne County, and Indiana, that approach has created a network of households that operate on their own terms, one generation after another. Once you understand that, the science behind it stops looking exotic. It becomes something much more important, simple, practical, and hard to ignore. The number that changes everything is 146 kilowatt hours a year. That was the figure NPR reported in 2007 for a single 2x4-foot solar panel used by Amish families in Ohio, enough to run several lights and a few small loads without ever connecting to the utility grid. To understand why that matters, you have to compare it with the electricity demand of a modern home, which the U.S. Energy Information Administration has long measured in the thousands of kilowatt hours per year, not the hundreds. In plain language, the Amish are not trying to power a suburban lifestyle with a tiny panel. They are designing the load around the power they can collect, and that is the first scientific principle most people miss. That principle is called matching demand to supply. Modern homes are built the opposite way. The house assumes abundant electricity first, then the family fills the space with appliances, chargers, screens, motors, and always-on convenience. The Amish method starts with scarcity and discipline. If a panel can only collect a modest amount of energy, then the family only assigns it critical work, safety lighting, small motors, pumps, or other tasks that justify every watt. This is not a moral preference, it is engineering. A system stays stable when the load is smaller than the supply, and when the storage is large enough to cover cloudy weather and nighttime use. Solar panels themselves are simple in concept but unforgiving in practice. A photovoltaic panel converts sunlight into direct current electricity through semiconductor materials. The best commercial panels today typically convert about 15% to 22% of incoming sunlight into electricity, depending on the technology and design. That means most of the sun's energy is still heat, reflection, or loss. A small panel is therefore not a magic machine. It is a controlled collector. If it gets about 1,000 watts of sunlight per square meter at peak conditions, a panel with 20% efficiency produces around 200 watts per square meter at that instant, and less in the real world once angle, shading, dust, wiring, and temperature are factored in. That is why Amish systems are usually small, not because the technology is weak, but because the use case is tight. A panel around 2 feet by 4 feet is roughly 0.74 square meters. Under ideal peak sunlight, a panel of that size could produce on the order of 100 to 150 watts depending on efficiency and conditions, and much less across the whole day once sunrise, sunset, clouds, and seasonal angle are included. Over a year, NPR's 2007 reporting described that kind of panel producing enough for around 146 kilowatt-hours annually in the Amish solar context. That number sounds tiny until you realize it can be perfectly sufficient when you are only powering a narrow set of tasks instead of a whole house of modern appliances. The storage side is just as important. Most off-grid Amish systems rely on batteries, and batteries obey physics that is very different from the psychology of ordinary consumer electricity. A battery does not create power. It stores it, then slowly gives it back. Lead-acid batteries, still common in off-grid and backup applications, are cheap and robust, but not perfect. Their charging efficiency drops near the top of charge, and their performance depends heavily on temperature, charge rate, and maintenance. A University of North Texas paper in 1996 on lead-acid battery efficiency near top of charge showed that design choices in photovoltaic systems must account for that loss, because the last part of charging becomes less efficient and more sensitive to overcharge. That is why Amish systems are usually conservative. They do not try to squeeze every last drop from the battery. They keep the loads modest so the battery survives. Here is the plain language version. If a battery is too small, it wears out fast. If a load is too large, the battery voltage drops and the system becomes unstable. If solar input is inconsistent, the charge controller has to manage the current so the battery does not overheat or degrade. In a small Amish setup, that means one well-sized battery bank can serve a few lights or a workshop task reliably. In a commercial grid-tied home, by contrast, the homeowner is not managing the system load at all. The utility is. The family just pays for whatever is used, which hides the real engineering cost inside a monthly bill. The science gets even clearer when you compare the Amish method with the commercial alternative. NPR's 2007 reporting noted that the modern grid-connected household would need about 100 times the Amish power use because a typical home includes washing machines, televisions, microwaves, and a long list of always-on loads. That means the Amish are not saving money by doing the same thing more cheaply. They are doing a fundamentally different thing. They are choosing a load profile that can be supported by a tiny renewable source. The average homeowner, if trying to live off-grid with the same lifestyle, would face a system cost around $20,000 in that same report. The difference is not just the equipment. It is the entire way the home is designed. This is why the Amish method is scientifically elegant. It avoids the biggest failure mode in off-grid design, which is trying to power a modern lifestyle with an undersized system. Engineers call that oversubscription. Families experience it as dim lights, dead batteries, noisy generators, and frustration. The Amish avoid oversubscription by choosing simplicity at the source. A light where they need one, a motor where they need one, a battery sized for the task, a panel matched to the battery. The result is a system that can remain off-grid for years without becoming a maintenance nightmare. Temperature also matters more than most people realize. Solar panels lose efficiency as they get hot, and batteries lose useful capacity in cold weather. The off-grid owner has to design for both realities. In practical terms, that means enough panel wattage for winter and enough battery reserve for cloudy days. The U.S. Department of Energy's rooftop solar guidance explains that rooftop suitability depends on tilt, shading, direction, and location, which is another way of saying that a panel's output is never just about the panel itself. Amish farms often place panels where they make sense for a specific structure, not where they would make a glossy sales brochure look nice. There is also a biological side to the story, even if it is less obvious. Human labor works best when it is not being stretched by constant dependence on the grid. When a family has simple, dependable light and a narrow set of powered tools, daily work becomes rhythm-based instead of interruption-based. A barn task gets done when the battery is ready. A shop tool runs when the solar input and storage allow it. That encourages planning, maintenance, and discipline. Modern electricity, by contrast, trains people to expect unlimited access at all times. That expectation changes behavior, which is why the Amish system feels so different even before you look at the numbers. The measurements tell the same story from every angle. A 15% to 22% efficient panel does not produce household-level abundance by itself. A 146 kilowatt-hour annual system is tiny compared with a modern home, but it is perfectly matched to limited loads. Lead-acid batteries become less efficient near the top of charge, so charging must be managed carefully. Off-grid design succeeds when the load is reduced first and the equipment is chosen second. That is the whole secret. And it is not secret because it is complicated. It is secret because it is inconvenient to a culture built around consumption. Once you see the science this way, the Amish method stops looking like a quaint exception. It looks like a disciplined energy model that many modern households could technically copy, but very few are willing to adopt because it asks a harder question. Do you want unlimited convenience, or do you want control? The Amish answer that question with their buildings, their batteries, and their bills. And the answer is written in the silence of a farm that keeps its lights on without ever asking permission. The part that should make you pause is not that Amish families found a way to stay off the grid. It is that the rest of the system was built in the opposite direction, toward dependence, recurring payment, and long-term control. Once you understand that, the silence around simple off-grid power stops looking accidental. It looks profitable. The financial structure of electricity in the modern world is built on consumption, connection, and monthly billing, while the Amish method is built on ownership, restraint, and one-time purchase. Start with the scale of the commercial market. In the United States, residential electricity is not a small line item. It is a massive, recurring revenue stream for utilities, equipment vendors, financing firms, and the regulatory ecosystem around them. The U.S. Energy Information Administration has shown for years that the typical home uses thousands of kilowatt hours per year, which means the commercial system is designed to sell a continuous service, not a one-time solution. Once a house is in that loop, every appliance, every upgrade, and every rate increase keeps the meter moving. That is the economic engine. That is why a tiny Amish solar system is so revealing. It bypasses the engine. The public story usually presents grid power as neutral infrastructure, but the economics are anything but neutral. The utility model depends on you using more, not less, and then paying again forever. A small standalone Amish-style system does the opposite. It front-loads the cost, shrinks the load, and then removes the recurring bill. That is not just a lifestyle difference, it is a revenue difference. And once you see revenue at that level, you can understand why the off-grid model is often treated as quaint rather than normal. The numbers are not subtle. A widely reported off-grid solar setup in Amish communities used a small 2x4-foot panel that could produce roughly 146 kilowatt hours a year. By contrast, a conventional home in the same NPR report was described as needing about 100 times that power use, with an estimated $20,000 system cost if the household wanted to live off-grid at modern consumption levels. That is the trap. If you keep the modern lifestyle, the off-grid alternative looks expensive. If you keep the Amish load, it becomes practical. The hidden variable is not the panel, it is the demand. That is the part the commercial system prefers you not to think about. The easiest way to make alternative systems look unreasonable is to compare them against a consumer pattern they were never designed to support. A modern home with air conditioning, electronic entertainment, constant charging, and all electric appliances is not the same problem as a barn light and a small motor. Yet the public conversation often treats them as if they are. That confusion protects the commercial market. It makes restraint look like deprivation and dependence look like normality. Look at the cost structure more closely. A 2025 Brazilian market article summarized installation prices at roughly $3,000 per kbp, with smaller residential systems around $6,000 and larger commercial installations rising to tens or hundreds of thousands of reais depending on size. In the U.S., California's 2020 solar requirement was widely reported as adding about $10,000 to the upfront cost of a new home. In other words, even the mainstream version of solar is still framed as a capital expense for people who can afford the entry fee. The Amish method goes further because it does not try to electrify every square foot of life. It stays narrow on purpose. That is why it is cheaper. Not because the hardware is magical, but because the demand is disciplined. This is where suppression becomes less about a single conspiracy and more about a structural bias. Utilities, appliance makers, fuel vendors, and financing companies all benefit when energy is sold as a permanent subscription. Solar companies often benefit too because they still make money from larger systems, larger batteries, and larger installations. The whole commercial ecosystem is aligned around selling bigger solutions to bigger loads. A tiny, low-maintenance, low-consumption system that eliminates most billing is not the model that maximizes quarterly revenue. It is the model that minimizes it. That incentive helps explain the tone of the public discussion. The Amish are frequently portrayed as culturally distinctive, not technologically instructive. Their choices are framed as religious custom rather than as a serious energy lesson. Yet the lesson is obvious once you strip away the stereotype. If you control demand, you control cost. If you keep the system small, you keep it affordable. If you avoid the grid, you avoid the recurring transfer of money from the household to the infrastructure owner. That is a powerful idea, and powerful ideas are usually softened when they threaten recurring income. The regulatory side matters too. When the conversation shifts from off-grid simplicity to grid-tied interconnection, the rules become more complex. Local utility standards, inspection requirements, metering policies, and building codes all add friction. That friction is often justified as safety or reliability, and sometimes it is. But friction also has an economic effect. It makes the independent option slower, harder, and more expensive to adopt. In practice, that favors the incumbent system. The Amish sidestep that entire layer by never making the public grid the center of the design in the first place. There's also a deeper historical motive. The industrial model of electricity flourished because it turned a natural resource into a managed service. Once that happened, households became customers instead of producers. Monthly bills became ordinary. Dependence became routine. And the idea of building a home around a modest amount of local generation, with storage and careful load management, began to look old-fashioned, even when it was economically rational. That is not a technical accident. It is a cultural outcome. People do what the system teaches them is normal. The Amish refused that lesson. They kept the household small, the energy local, and the authority distributed inside the family and church district instead of outsourced to the grid. That has a financial consequence that is almost too simple to say out loud. Every kilowatt hour they do not buy is money they never send away. Every appliance they do not add is a future bill they never create. Every panel they install to serve a narrow purpose is an expense that ends the moment it is paid for. That is why the system is so durable. It is not just spiritually disciplined, it is economically resistant to extraction. And the numbers keep pointing in the same direction. If a panel produces a modest annual output, if the battery is used carefully, if the family only powers essential loads, then the cost remains contained. If, on the other hand, the home is built around full grid expectation, then the bill becomes permanent and the ownership ends at the meter. The difference is not just in watts. It is in who gets paid year after year. That is the financial motive laid bare. The commercial system does not merely sell electricity, it sells the habit of needing it. The Amish method threatens that habit by proving that a family can live with a fraction of the demand, a fraction of the infrastructure, and none of the monthly dependence. And that is why the quietest part of this story is the loudest. The system was never hidden because it failed. It was hidden because it worked too well for the wrong people. If you want the Amish-style result, the first thing to understand is this. You are not building a whole-house power company. You are building a small, disciplined, stand-alone system for a specific job. That is the difference between a system that stays affordable and one that becomes a money pit. A basic 200-watt off-grid starter kit with panels and a 30-amp PWM controller was listed at $209.99 at Home Depot in 2023, while a more complete 200-watt kit with an MPPT controller was listed at $399.99 by Rich Solar. In other words, you can start small, learn the system, and avoid the huge upfront cost of trying to electrify everything at once. Choose the job first. Decide exactly what you want the system to do before you buy a single component. The safest beginner target is one of these: barn safety lights, a small workshop light, a phone charging station, a radio, a small water pump, or a few LED fixtures in a shed. Do not begin with air conditioning, microwaves, or whole house backup. That is how people blow up budgets and batteries. If your goal is a light and a small load, then a 200-watt to 400-watt system is a sensible first build. If your goal is a cabin, small shop, or light-duty farm building, you can still stay in the same range, just with better planning and a larger battery bank. Buy the core parts in the right order. A simple system needs 4 essentials: solar panel, charge controller, battery, and load wiring. For a starter build, use 1 or 2 100-watt panels or one 200-watt panel, a 20-ton to 30-amp charge controller, a 12-volt battery, and LED lights or another low-draw load. A practical parts budget in 2026 is about $200 to $500 for the small end and about $100-300 or more for a larger starter setup with a lithium battery and inverter, according to current DIY market guides. Keep the first build modest. If you oversize the panels before you understand the battery, you create maintenance problems instead of freedom. Pick the battery correctly. For the easiest beginner path, use a 12-volt LiFePO4 battery if you can afford it. The reason is simple. Lithium batteries tolerate deeper discharge better than lead acid, weigh less, and need less maintenance. A 12V100AH lithium battery gives roughly 28 kilowatt-hours of nominal storage, which is enough for lights and small electronics, but not for high-draw appliances. If you want lower cost upfront, AGM or deep cycle lead acid can work, but they should be treated gently and not regularly drained too far. For Amish-style reliability, the key is not max capacity. It is matching the battery to a small, predictable load. Mount the panel where the sun actually hits it. Face the panel toward the best available sun at midday. In the northern hemisphere, that usually means south-facing. Keep it away from trees, chimneys, and shadows because even partial shade can cut output hard. Home Depot's installation guidance for starter kits says to position the panel to avoid shade, and notes that moving the panel seasonally may be required for better performance. Use a secure roof mount, a wall mount, or a ground stand. If you are in a windy area, do not use a flimsy bracket. If the panel moves, your output and safety both suffer. Wire the charge controller first, not the panel directly to the battery. This is the step beginners get wrong. The correct order is battery to controller first, then panel to controller, then load to controller or battery, depending on the controller design. The Home Depot installation guide explicitly says to connect the positive battery lead first and then the negative, and to connect the solar panel positive first and then the negative. That order matters because the controller needs to see battery voltage before solar input. It helps it regulate properly and prevents damage. If you skip the controller or wire it backward, you can ruin the equipment fast. Use the right wire size and fuse the positive line. For a small 12-volt system, use short wire runs and do not undersize the cable. Thicker wire reduces voltage drop and heat. The starter kit guide notes a total of about 30 feet of wire in one kit and recommends keeping the controller close to the battery and the panel to reduce losses. Put a fuse on the positive battery line as close to the battery as practical. That fuse protects the wire if something shorts out. A beginner-friendly setup often uses 10-gauge or 8-gauge wire for short runs, but the exact size depends on distance and current. The rule is simple. The longer the wire, the thicker it should be. Add the load the Amish way. One purpose, one circuit. Do not wire every outlet in a building to the system. Start with one dedicated circuit for one job. For example, put 2 LED lights in a barn aisle, or one light and one small fan in a workshop. Low-voltage LED lighting is ideal because it gives useful light for very little power. If you want an inverter for AC devices, keep it small, around 300 watts to 1,000 watts for the beginner stage, and use it only when needed. The more the system tries to imitate a normal house, the faster it stops behaving like a simple off-grid solution. Size the output around your actual daily use. If you run 4 10-watt LED lights for 5 hours, that is only 200 watt-hours a day. If you charge phones and a radio as well, you might still stay under 400 watt-hours. That is a tiny load compared with the thousands of watt-hours used by a normal home. A small 200-watt solar array can cover that kind of use on a decent day, especially if paired with battery storage. If you need a little more margin, move to 400 watts of panels and a larger battery. The goal is not to create excess. The goal is to keep the battery comfortably charged. Plan for regional climate differences. If you live in a northern climate with winter snow, short days, and low sun angles, oversize your panel array by about 25% to 50% compared with a mild climate build. Winter output falls because of shorter daylight and lower sun. In practice, that means a system that is fine in Tennessee may struggle in Minnesota unless you add panel area or reduce loads. If you live in a hot desert climate, you still need shading management and ventilation because heat reduces panel efficiency and batteries hate extreme heat. In desert regions, keep the battery in a shaded, ventilated enclosure and leave space under the panel for airflow. If you live in a snowy region, mount the panel at a steeper angle so snow sheds more easily. Adjust for coastal or humid regions. Salt air, corrosion, and humidity attack metal fasteners and electrical contacts. In coastal areas, use stainless hardware where possible, seal all roof penetrations carefully, and inspect connectors more often. In humid regions, keep batteries elevated off damp floors and use a dry, ventilated enclosure. Moisture is a silent system killer because it creates resistance and corrosion that people do not notice until performance drops. That is one reason simple systems work best, when they are inspected regularly rather than left alone for years. Avoid the one mistake that ruins beginner systems. The most common mistake is trying to power a normal appliance load with a tiny battery bank. A small inverter can start a phone charger, a light, or a laptop, but it will struggle or fail with a microwave, hair dryer, or space heater. The way to avoid the mistake is to check the watt rating of every device before connecting it. If the appliance is high draw, leave it off the system. The Amish logic applies here too. If the load is too large, the system is no longer simple. It becomes expensive, fragile, and disappointing. Test the system in stages. After wiring, test the battery voltage first, then the controller display, then one small load at a time. Do not add everything at once. Watch how the voltage changes when a light turns on. Watch how the controller behaves at sunrise and sunset. If the battery is not charging fully, check for shade, loose connectors, or too much distance between the panel and controller. If the battery drains too fast, your load is too large or your panel too small. That feedback loop is the heart of off-grid learning. It teaches you to think like a steward instead of a consumer. Keep a maintenance routine. Once a month, inspect every connector, look for corrosion, tighten fasteners, and wipe dust from the panel if needed. Every season, check the angle and make sure shadows have not changed because of tree growth. In winter, clear snow if it is safe to do so. In summer, make sure the battery space is not overheating. For lead-acid systems, check manufacturer guidance on water levels if the battery type requires it. For lithium systems, keep the battery within the recommended temperature range and avoid extreme heat. The simplest systems stay alive because someone pays attention to them. Know when to stop and scale later. If the system starts doing its job well, resist the temptation to keep adding loads. Add only one thing at a time, a light first, then maybe a pump. Then maybe a small inverter for one device. That progression keeps the system understandable. It also keeps the cost honest. A small off-grid system is powerful because it stays small enough to control. Once it gets large enough to mimic a normal utility account, it loses the whole advantage. The reason this approach feels so clear once you see it is that it asks for discipline instead of dependence. That is the part most people were never taught, and it is exactly why the method stayed out of the mainstream for so long. If you want to know whether a simple off-grid logic can survive outside a farm, look at the places where the stakes are larger, the engineering is stricter, and the results have to be measured. The same principle that keeps an Amish family out of an electric bill has been proven in major buildings and public infrastructure around the world. Reduce demand, localize supply, and design for the actual job instead of the fantasy of unlimited consumption. One of the clearest examples is the Bullitt Center in Seattle, Washington, USA, completed in 2013. It is a 6-story office building designed to operate as a net positive energy building, and its documented photovoltaic array produces about 242,000 kilowatt-hours per year, while the building's annual electrical demand is kept around the same scale through highly controlled use, efficient lighting, and load discipline. The important part is not just that it has solar panels. It is that the building was designed so the panels could actually cover the load without pretending the grid was the solution to every problem. That is the same logic the Amish use on a smaller scale. Keep the demand low enough that a modest system can carry it. What makes the Bullitt Center so useful as proof is that it is not a stunt. It is not a prototype hidden in a lab. It is a functioning building used for work, with published performance data, and a design that treats energy as a budget instead of a bottomless resource. The lesson is plain. If the load is carefully controlled, a local generation system can do serious work in a real building. That is exactly what the Amish understand at the farm level, except they apply it with fewer inputs and less ceremony. A second strong example is The Edge in Amsterdam, Netherlands, completed in 2014. It is widely documented as one of the most energy-efficient office buildings in the world, with about 28,000 sensors, a large rooftop solar array, and a design that drastically reduces power waste through lighting controls, smart shading, and efficient systems. Public reporting on the building has described it as producing more energy than it consumes under ideal conditions, with a net positive performance profile supported by its integrated solar and automation systems. The point here is not that it copies Amish life in style. It does something more important. It proves that when a building is designed around low demand and local generation, the old idea that everything must be fed by a distant utility starts to collapse. The Edge also shows something else that matters. It uses a lot of technology to achieve what the Amish achieve with a lot less technology: control. The building systems are designed to eliminate waste before it becomes a bill. That is the same first principle behind the Amish farm. You do not begin with excess and then try to manage it. You begin with restraint. That is why the Amish method looks simple and the modern version looks complicated. They are solving the same energy problem from opposite directions. A third example is the Maggie Center at Charing Cross Hospital in London, United Kingdom. Opened in 2008 and widely reported as a low-energy, highly efficient building with a carefully designed natural light strategy and reduced mechanical demand. While it is not off-grid in the Amish sense, it demonstrates the same core principle at institutional scale. The building's energy demand is low because the architecture itself does the work. Large windows, passive daylight, and reduced reliance on constant electrical systems keep the load down. That matters because it proves the logic is not limited to cabins, farms, or hobby projects. It works in professional buildings where the cost of being wrong is high. Across these examples, the technical pattern is consistent. First, reduce the load. Second, generate locally. Third, store or manage the output. Fourth, avoid wasteful dependency. That sequence is the real infrastructure lesson. It is not glamorous, but it is durable. And durable systems are the ones that survive long enough to matter. If you look at the numbers, the lesson becomes even harder to dismiss. A building like the Bullitt Center can generate in the hundreds of thousands of kilowatt-hours per year because it was designed with efficiency from the beginning. A building like the Edge uses automation and solar to suppress waste before it grows into a cost. A low-energy facility like Maggie's Center uses architecture to cut the load before the meter ever starts running hard. The Amish farm does all of this with a much smaller footprint and a much stricter discipline. That is why the comparison is so powerful. The global proof does not replace the Amish example. It confirms it. And that confirmation matters because it removes the excuse that this only works in theory. It does not. It works in office towers, in healthcare facilities, in high-profile commercial buildings, and in places where energy is measured, audited, and compared to the standard model. If the same core principle scales there, then the farm version is not a relic. It is a stripped-down application of the same engineering truth. The real takeaway is simple. The Amish did not invent physics. They aligned with it. They built around limited demand, local supply, and practical storage, long before the rest of the world started calling those ideas innovative. The modern buildings prove the approach at large scale. The Amish farm proves it at human scale, and that is why the scene at the beginning matters so much. The little panel on that quiet farm is part of the same story as the famous green buildings of the world, only with fewer headlines and far less waste. Now I want to hear from you, because this is where the story stops being just about one Amish farm and starts becoming about your life, your state, and your own electric bill. Drop your state in the comments and tell me what you pay for the commercial alternative right now. I want the real number. I want the monthly cost, the seasonal spike, the rate that keeps creeping upward, the bill that shows up whether you used much power or barely any at all. Because once people start comparing real numbers, the whole conversation changes. It stops being abstract. It becomes personal. And that is exactly why this channel exists. Tradition done right is not here to repeat the same safe stories everybody else repeats. It is here to show you the systems, the methods, the old knowledge, and the practical truth that still works when the noise is stripped away. If this video hit you, subscribe right now and turn on notifications. Not as a casual favor. Do it because the algorithm will not bring this to you on its own. If you leave it to the feed, you will get whatever is easiest to promote, not whatever is most useful to know. You have to choose to stay. That is the part modern platforms never say out loud. They do not reward patience. They reward distraction. They do not reward independence. They reward whatever keeps people scrolling, buying, and forgetting. So if you want this kind of documentary work in your life, you cannot treat it like background noise. You have to make the choice intentionally. Subscribe, turn on notifications, and keep showing up for the ideas that actually help you understand how ordinary people built extraordinary resilience. And look at what we learned here. A small panel on an Amish farm is not a gimmick. It is not a cute local trick. It is the visible edge of a whole system built on discipline, local control, and refusal to be trapped by recurring dependence. That is what makes it so powerful. The same logic scales into major buildings, but it starts with the same basic decision. Stop letting demand grow faster than your ability to support it. That is why this matters beyond electricity. It is about who controls the system. It is about whether you live by design or by subscription. It is about whether your life is built around ownership or endless payment. The Amish answer that question with quiet consistency. They do not need to announce it. Their farms already say it. So leave your state in the comments, and while you are there, tell me what you currently pay for the commercial version of this problem. How much is the bill? How much has it changed in the last year? How much of that money feels like service, and how much feels like surrender? Those numbers tell a bigger story than most people realize. They show how much control you still have, and how much has already been handed away without being named. The next video is going to push this even further, because what I found next is worse than a high bill. In the next one, I am going to show you how one common modern household system costs families thousands every year, while a simpler off-grid method can run for decades with almost no maintenance. The shocking part is not just the price. It is the fact that the expensive version became normal so quietly that most people never questioned it. That is the kind of hidden structure that changes how you see everything around you. And that is why I keep coming back to these stories. Because once you see how a family can live with less dependence and more control, you cannot unsee what the mainstream model was asking you to accept. The numbers are real. The savings are real. The discipline is real. And the freedom is real. The quiet truth is this: the people who built the simplest systems were often the ones who understood them best.